Hey everyone, Sukanya here. Today we're going to be taking a look at how to solve this integral, integration e to e squared of 1 over log x minus 1 over log x squared dx. And I'll give you a hint. We have to apply integration by parts to solve this integral. But before we do that, I actually want to simplify this integral. And instead, I'm going to break this integral into two integrals. Now what I'm going to do, I am going to apply integration by parts like I said earlier, but I'm actually just going to do it on the first term. And the reason I'm just going to do it on the first integral is that most of the time when you have two integrals and you're applying integration by parts, hopefully once you apply integration by parts on the first term, maybe one of those new terms that you get will cancel out with this. So when you apply integration by parts, you're going to get basically two terms. You're going to get one term over here and another term over here, and then this term is just going to stay the same. Hopefully, I'm hoping that this term and this term get canceled. Maybe it's a different positive and minus sign that they can cancel each other out. Alright, so I'm going to apply integration by parts on this integral. In order to apply integration by parts, I do need a second function. So we have our first function over here, 1 over log x. Our second function, that's just going to be 1. So I'm just going to say that is 1 dx and minus. So we have our two functions, and now what I'm going to do, I'm going to forget about these bounds when I'm doing integration by parts. I feel that it's easier to find the final integral and then put in the bounds. Not worry about them right now, just worry about getting that integration by parts set up. So integration by parts says that we have our first function, log x, integration of our second function, dx, minus integration of the derivative of the first function, which is minus 1 over x log x squared. And I just derived that from basic chain rule, times integration of our second function again. And that's it. And this term is going to stay just the same over here. Now let's start to simplify. Alright, so I essentially simplified this. Integration of 1 dx is just x, so that x is over here. And same thing, that x is over here because we have an integration 1 dx. I noticed that in the second integral, this x and this x cancel out. And hence, I noticed that this term and this term can also cancel each other out, which is exactly what we wanted. We're left with x log x. And now we can bring back those bounds. So we have e squared. Now we can simply substitute it. And this is going to be our final answer.